Here is an important point to note about sample size. For most applications, a sample size of 30 or larger will be good enough. But if the population distribution is highly skewed or contains outliers, then you may need a sample size of 50 or more in order to use the normal approximation for this procedure. Here is something to consider. What will happen to the margin of error if your degree of confidence increases, if you want your degree of confidence to increase? Second, what will happen to the margin of error when the sample size increases? Third, what will happen to the margin of error when the standard deviation of the population sigma increases? Now let's consider the second case, where we do not know the standard deviation of the population. If it cannot be found, then we will have to use the standard deviation of the sample, and we will construct our interval estimate for the population mean. But here is an important point. We will be using the so-called t-distribution rather than the normal distribution. For now, we'll assume that the population is normally distributed. Please take a minute to read the description of the t-distribution. The key thing here is that the t-distribution is also a probability distribution. Another important thing to note is that we will have to take into account the so-called degrees of freedom in order to use the t-table which is provided in the textbook. As the degrees of freedom increases, the difference between the t-distribution and the standard normal probability distribution becomes smaller and smaller. And if the degrees of freedom are large enough, we may as well use the standard normal. Here is a picture of the t-distribution. As you will see, it looks very much like the standard normal. It's symmetric, but it's just that it's flatter. But as the degrees of freedom increase, it becomes steeper and steeper, and eventually becomes pretty similar to a standard normal. And if you actually have more than 100 degrees of freedom, then you may as well use the standard normal z-table. Or you can use the last row of the t-distribution. This is shown in this illustration. Now here is the formula for constructing an interval estimate if you do not know the standard deviation of the population. As you will see, it looks very similar to the previous equation, right? In this case, it's x bar plus or minus the critical t, and then multiply it by the standard deviation of the sample and divide by the square root of the sample size. So the key thing here is being able to determine the critical t value. As I said, it will be important for us to know the degrees of freedom. How do we determine the degrees of freedom? It's just n minus 1. So if we have a sample size of 30, degrees of freedom 29. If we have a sample size of 50, degrees of freedom 49. So consider this example. Please take a minute to read the description. We want to construct a confidence interval estimate such that we can be 95% confident that the true population mean rent is within that interval. So we know the sample standard deviation 55. We know the sample mean x bar 750. We know the sample size n, small n, 16. Hence the degrees of freedom will be n minus 1 or 15. Please keep this in mind. Now look at the table. We are looking for the critical t, and that critical t will be the intersection of the degrees of freedom and the area in the upper tail. Remember, we want to be 95% confident. Hence, the area to the right and to the left must equal 5%, or each area must be equal to 2.5% or 0.025. Use your finger to trace the intersection, 15 from the column and 0.025 from the heading row. They intersect at 2.131. Hence, our critical t is 2.131. Now, having obtained the critical t, plug that number into the formula. Remember, x bar is 750 and S, the standard deviation of the sample, is 55. Plugging them all in, and we get 650 plus or minus 29.3. Hence, we can be 95% confident that the mean rent for the population of apartments will be between $720.70 and $779.30. Again, regarding adequacy of sample size, n equals 30 or greater will probably be okay. But if you know that the population distribution is highly skewed, then you may need to use a sample size of 50 or more in order to use the procedure we have described. And if the population is not normally distributed but is roughly symmetric, then n as small as 15 may be okay. And is approximately normal, then even less than 15 will be okay. Hence, this is the flow chart. If you know the population standard deviation, then that's the situation to the left. Use the z value and use the standard normal table. If you do not, then use the sample standard deviation and also use the t table with degrees of freedom n-1. Let us now consider the desired margin of error. So before, we were constructing the interval estimate, and with the desired margin of error being dictated by our degree of confidence. Please take a minute to read the description. As you can see in this case, we set the desired margin of error, and then we work backward to get the sample size that is consistent with our desired margin of error. And here are the formulas. Given the margin of error, we can determine the necessary sample size from the equation at the bottom. Now take note though that we would require the population standard deviation sigma. If it is unknown, then we may have to use the following steps. First, you could use a population sigma that you've obtained from a previous study. Use a pilot study to select a preliminary study, or use your best judgment or best guess for the value of sigma. And now let's consider this example. Please take a minute to read the description. So now, the question is, we are trying to estimate the sample size needed so that we have a 95% confidence that the sampling error will be $500 or less. Please take note, we do not even need to know the sample mean, as you will see from the equation. All we need to know is the population standard deviation and the margin of error that we have specified. So this is the equation. Remember, for 95% degree of confidence, the critical Z is 1.96. Also remember that sigma is 4,500, and therefore just plug in all those numbers and we will get the sample size that's warranted. In this case, we need 312 observations in order to be 95% confident that the sample mean will be within the desired precision of plus or minus $500. Let us now consider constructing interval estimates for the population proportion.